Hi everyone, so here is a video with 5 questions that are all volume of gas calculations. This is a higher tier topic. So as always, pause the video when you get to a new question, give it a go and then replay when you are ready. Here is question 1. So we are told that the volume of 1 mole of any gas at room temperature and pressure is 24 decimeters cubed. So to find out the volume of any other number of moles, we just need to multiply that number of moles by 24. So the information we've been given is a mass of chlorine and also the MR of chlorine. So using mass and MR, we can work out number of moles. Number of moles N is the mass divided by the MR. Okay, now the mass we've been given is in kilograms, and the mass in this formula should be in grams, so we need to times by 1,000 to convert to grams. And now we can plug into the equation N equals M divided by MR, and we've got 150,000 divided by 71. So that gives us this many moles of chlorine gas. Now we're going to use this equation that I've written here. The volume is the number of moles times by 24. So it's going to be 2112.676 times 24, which is 50,704 decimeters cubed. Okay, here's question 2. Pause the video, give it a go and replay when you are ready. So we have been given the volume of hydrogen and it's 825 decimeters cubed. So we can use this mole ratio of hydrogen moles that are reacted and how many ammonia moles are formed to find out the volume of ammonia. Okay, so the number of moles of hydrogen to ammonia in the equation we've been given is 3:2. Okay, now the volume of hydrogen that we have is 825. So to get from 3 to 2, you have to divide by 3 and times by 2. So that's what I'm going to do, the same to this volume here. I'm going to take 825, I'm going to divide by 3 and times by 2. And that comes out as 550 decimeters cubed of ammonia. Here's question 3. Pause the video, replay when you're ready. So we want to know the number of moles of chlorine collected after 20 minutes. So what we can do is read the graph up from 20 minutes, read across on the chlorine line and find out the volume of gas of chlorine collected. So if we read up from 20 minutes, and we hit the chlorine line right here, and then read across, and we get a volume of 6.6 centimeters cubed. So the volume, 6.6 centimeters cubed. We need the volume to be in decimeters cubed, so to convert centimeters cubed to decimeters cubed, we need to divide by 1,000. If you put 6.6 divided by 1,000 into your calculator, it's probably going to say 6.6 times 10 to the minus 3. Okay, so if you remember from question 1, the volume of any gas at room temperature and pressure will be the number of moles times 24 decimeters cubed. Okay, so we have the volume, the total volume of gas. What we want to do is work out N, the number of moles. So I'm just going to substitute in the number that I know. V is 6.6 times 10 to the minus 3. That equals N times 24. So to find N, I'm going to do 6.6 times 10 to the minus 3 divided by 24. And that comes out as 2.75 times 10 to the minus 4 moles. And by using my calculator, I've actually already got my answer in standard form. Here's question 4. Pause the video, replay when you're ready. Okay, so we've got a volume of carbon dioxide that is made, and we've got a volume of oxygen that was burned, but we can see that was in excess because there's some unreacted oxygen. So to find out the exact amount of oxygen that reacted, we can use the volume of carbon dioxide we've been given and the mole ratio of carbon dioxide to oxygen. Okay, so carbon dioxide to oxygen, there's 3 moles of carbon dioxide made when 5 moles of oxygen reacts. So to get from 3 to 5, you have to divide by 3 and times by 5. Now the volume of carbon dioxide produced was 3.6 decimeters cubed. So I'm going to do the same thing to this number as what had to happen to get from 3 to 5. We divide by 3 and times by 5. So that gives us a volume of oxygen of 6 decimeters cubed. That is the amount that reacted. Okay, so what we can do is just take this total amount of oxygen, take away the amount that reacted, and we will get the amount that was unreacted. So 7.25 take away 6 is 1.25 decimeters cubed. Now it's asked us to give our answer in centimeters cubed, so to do that we need to multiply by 1,000. Here's the final question, question 5. Pause the video, replay when you're done. So we've got the amount of energy released when 1 mole reacts. It's 290 kilojoules. So I'm just going to convert that to joules first of all, so that we can compare numbers more easily. So 290 kilojoules, to turn it into joules, I need to multiply by 1,000. So that is the energy released from 1 mole. Now the actual energy released is 58 megajoules. So 58 megajoules. So this number, to convert that to joules, I need to multiply by 1,000,000. So I'm just going to add 6 zeros on. So that's what's released in total. So to find out the number of moles, we just need to find out how many times this number goes into the bottom one, and that will tell us how many moles were reacted. So we're going to do 58 million divided by 290,000, and we get 200 moles were reacted. Now we've got that same equation where the total volume that a gas occupies is the number of moles times 24, because each mole occupies 24 decimeters cubed. We've got the number of moles here, so we just need to do 200 times 24, which is 4,800 decimeters cubed.